Welcome to qnawire.
In this question, we have this reaction when we have one photon that is at rest and then another proton that is turned onto it. And they will have this reaction. Two protons produces still two protons, but they produce a particle and an antiparticle, and a negative kappa. So with a stationary target, only part of the initial kinetic energy of this moving proton is available. So momentum conservation tells us that there must be some non-zero momentum after the collision, which means that there must also be some leftover kinetic energy. So not all of the initial energy of this collision is available in this product, because part of the initial energy will remain as kinetic energy. So you cannot simply just do the addition and subtraction of the mass, because you have to consider kinetic energy in this case. So we have to use the other formula, that the available energy, EA squared, is 2 times m squared EM plus mc. So we need to use this equation for two particles of equal mass when one is initially stationary. So minimal available energy must be equal to the rest mass energy of the products. So which in this case is just two protons and a K plus and a K minus. So the available energy must be at least the sum of the final rest energy. Let's first find the available energy. The available energy must be at least the sum of the rest energy as the energy of these particles. So the available energy will be at least 2 times proton plus 1 times K plus kappa plus 1 times kappa. And one has a mass of 238.3 MeV. K plus has 493.7 MeV. Minus is also mass 493.7 MeV. So this is a total of 2.864 electron. So now let's go back and look at this equation. We want to solve the energy formula for EM. Using this, we will have EM equals EA squared over 2mc squared minus mc squared. So this will be 5864 MeV squared over 2 times this is MP protons, MC is going to be 938.3 MeV, subtract another 938.3 MeV. This is 32.6 MeV. So this is the total of the proton when the two protons collide with each other. But this total energy of the proton, remember that it also includes the rest energy. So we have to subtract the rest mass energy so that we only have the kinetic energy left. So the kinetic energy is the total energy of the proton. The rest mass energy, so that's again mpc squared. So it's 3432.6 MeV. So another 938.3 MeV. And a total of 2494 MeV. This is the amount of kinetic energy that is carried by the proton, and this is going to be the threshold kinetic energy in this reaction.